Okay, so talking about 6.4, still the AC method, we're looking now at problem 2. The daily revenue for a food cart is estimated by, and here's the revenue, so they have just this revenue equation, where X is the number of employees on duty. Find the revenue for 3 employees working. So they're telling us X is the number of employees. Well, if they say 3 employees are working, we would have X is equal to what? 3. So we are going to find the revenue, R of 3. This is function notation. Anywhere we see an X, what are we going to substitute? 3, right? Plus 360 minus 3 times 3 squared. Now, in order to find that, I'm just going to plug that in right now on my calculator. 66 times 3 plus 360 minus 3 times 3 squared. And we get 531, right? So this would be 531 is the revenue for 3 employees working. Why might the revenue increase or decrease in the food cart based on the number of employees? What do you think about that? Oh, right. But why does your revenue, if you, okay, so that's a good point. So fewer employees means you can serve fewer customers. So some people might leave. The line is too long, right? But then you might also, and actually this comes back to the idea of the graph of the quadratic. So right now, if we were to graph this, because our x squared term is negative, the parabola, and we haven't talked much about parabolas yet, but the parabola is going to open downward. So you have the revenue, and down here is the number of employees. Now, if I don't have if I have 0 employees, am I going to make very much money? No. And actually, it's the y-intercept here is 360. So I'm going to actually make $360 if I have no employees, because maybe I'm working the cart, right? And I get to just keep all the money. I don't have to pay anyone. But what if I had like 10 employees? Let's just imagine out here is 10, okay? If I have 10 employees and there's nobody really there, I have a lot of employees that I have to pay. So doesn't my revenue go down at a certain point? Like that's why, at a certain store, maybe let's think about Subway sandwiches for a second. If you had a bunch of employees standing around, it's going to cost you money, right? Whereas if you don't have enough employees, it's also going to cost you money because you're going to lose customers. But certain place, there's a certain sweet spot here where I would maximize my revenue and I would have the right number of employees to serve the right number of customers. This is the spot that I want to find out. And later on, we're going to find out when we do more with graphs of quadratics, we're going to learn about the vertex, okay? So the vertex would give me the maximum revenue, okay? And it would tell me how many employees do I need to maximize my revenue if this is my number of employees, okay? So you're right. Why might you? I'm not going to write out that whole sentence. We've just basically discussed it. As you have fewer employees, you serve fewer customers, you make less money. But as you have too many employees, you have to pay them and you can't make as much money. On a certain day, the revenue was $615. Find the number of employees working that day. So you see here from the equation, I'm going to write it in standard form. This is the revenue function equals negative 3x squared plus 66x plus 360. Now, when we were talking about linear equations, does everybody remember y equals mx plus b? And you notice how this is our constant here. If we had 0 employees, meaning x was 0, how much money would we make, our revenue? 360. Right now, that would be with 0 employees. So that right there is our y-intercept. That's how much revenue we would make with 0 employees. I want to figure out how many employees do I need to have a revenue of 615. So I'm going to plug in the number 615 for the revenue, and we're going to solve for x. Now, we were just talking in the last video, how could we solve this quadratic for x? Notice I can't isolate x. I have it in two places, right? So how could I get x by itself? What would I want to do first? Yeah, actually, the first thing we want to do is set it equal to 0. So number one step first, set equal to 0. Because we want to solve where r of x is equal to 615. So we plugged in the 615 because it wasn't that the revenue that they were asking us. Yes, 615 was the revenue. Okay, so the first thing I'm going to do is set it equal to 0. Why 0? Does anybody know what that is? Yes, negative 255. Oops, 55. That would make a difference. Does anybody remember why we're setting it equal to 0? Yeah, but why did I do that? What's the whole thing about 0? Why do I care about setting it equal to 0? Because I want to be able to factor it. And remember, my two factors have to multiply to 0 so that I know how to solve for them, right? So what could I do next to solve? The AC method, okay? And I might even want to check. I know that 3 goes in here. Does 3 divide evenly? Yes, actually it does. Do you know how to tell if a number is divisible by 3? This is a totally off-topic subject, but if you add the digits, 6 plus 6 is 12, 3 goes into 12. What's 2 plus 5 plus 5? Also 12, and 3 divides evenly into 12. 3 actually divides in here 85 times. I know just because I checked it on my calculator. So the number one rule of factoring is going to be divide out. When we're solving, we can divide out the greatest common factor. So right here, negative 3 is the GCF. 0 equals, because are you all groaning? If you were going to have to factor by multiplying 3 times 255 and come up with all the factors of that number, that's where we would want to use our calculator, right? So we get x squared. What does this become? Minus 22x, and here is plus 85. Is that easier to factor? Oh, yeah. Okay, so now what are we going to factor? We want factors of 85. Factors of 85, because AC, this is now a 1, right? 1 times 85 is 85. We could use a calculator for this. We go to y equals. Remember how we did this before? 85. I'm deleting that extra number. Second table. Numbers, we're looking for two numbers that multiply to 85 that add to 22. You see that? Oh, on the table? 5 times 27. Or no, 5 times 17. 5 times 17 multiplies to 85. Negative, negative adds to negative 22, right? Negative times a negative would give us a positive. So I just found the positive ones, but I knew if I added negative 5 and negative 17, I would get negative 22. If you scrolled up to the negatives up here, you would see that you also have negative 5 times negative 17, and there it adds to negative 22. Okay, so now we have 0 equals x minus 5 and x minus 17, right? Are you with me? So what does x have to be? In order for this to give you 0, x minus 5 equals 0, x minus 17 equals 0. Add 5 to both sides, we get x equals 5. Add 17 to both sides, we get x equals 17. So how many employees do I need to make a revenue of $615? 5 and 17. So let's go back up here to the graph. Here's 615. I need 5 employees. Here's 615 again. or I need 17 employees. So halfway in between, because the thing we're going to learn about parabolas, they have symmetry, halfway in between 5 and 17 is the vertex. Can anyone tell me what they think that vertex would be? What would be halfway in between 5 and 17? Oh, how would, let's see. Oh, 22. Oh, 22 divided by 2 is 11. Is 11 halfway in between 5 and 17? So you added the two numbers and divided by 2, and you got 11. If I count up 6, I get 11. If I count down 6, oh, so we actually know that the maximum revenue would be if we had 11 employees. Does everybody see why that would be true? Let's find out, just for fun, what would be the revenue of 11 employees? Negative 3 times 11 squared plus 66 times 11 plus 360. How much would the revenue be? And I'll just use my calculator, second quit, something like this, second quit. Okay, negative 3 times 121, because I know that's 11 squared, plus 66 times 11 plus 360, 723. And you can see that that's the highest amount of revenue that's here because we were talking about 615. So this spot right here, the vertex is 11,723. But don't worry, we're going to have a formula for how to solve that. But I like how you guys are using your reasoning skills to like just see the shape, see what the pattern looks like. Is this kind of making sense? Okay, did we have any other questions to answer on here? I think we answered it. Yes, yes? Uh-huh. Yes. Okay, I can definitely talk about that. Yes, let's talk about that. Okay, so the whole thing about factoring is, and by the way, we should write this in a sentence answer. So it would take 5 employees or 17 employees to make a revenue of 615. So here we started by plugging in the revenue of 615. In order to use this method, we have to always set it equal to 0. So what I started by saying was the zero product property. The only way that this works is if we set it equal to 0, because if I said, okay, what number, if I said two numbers that multiply together to give you 615, do you know definitively what those two numbers are? No. They actually could be an infinite number of numbers. But if I said two numbers that multiply together to give me 0, do you know definitively what one of those numbers would have to be? Has to be 0. So that's the reason why we use the zero property, the zero product property. Yes, it's a control. I like that. Yes. So we're always going to plug in the number that we're trying to solve for, but our first step is always going to be to set it equal to 0. Okay, and that's a lot of times why we say, well, you know, how many employees did you have if your revenue was 0? Then you would just be plugging in revenue of 0, right? Okay, and then notice that the maximum revenue, that's the vertex. Okay, we'll stop this one. We'll do the third word problem on the next video.